Hey guys, so today we're going to be talking, our learning target is going to be we will be able to solve system of equations through substitution. Okay, so you should remember that all week, for like the next 2 weeks, our learning target is basically we will be able to solve system of equations. Okay, and on Monday we talked about solving through tables. On Tuesday we talked about solving by graphing. On Wednesday, that's today, we're going to talk about solving through substitution. So a good essential question is, how do I substitute something? Okay, so our first question that we're just going to dive into together right now is this problem right here. And it says, solve the following system for y. So in other words, what it wants is it wants me to get y equals. Okay? And it actually specifically for this problem, it wants me to get y equals some number. Okay? So you are actually trying to find the value for y. Okay, so we have two equations here, so that makes it a system. A system is just when you have more than one equation. Okay? So, in this case, we have two equations. Alright? You could have more. You could have 2, you have 3, 4, 5, 6, 7, an infinite amount. Okay? We're going to solve through substitution. So how do I substitute something? Well, guys, you should remember that substitution means, like, let's pretend that you had some random thing. You had 3x plus 6 equals y, and I told you that x equaled 4. Okay? So then you could substitute the 4 in for x. Since you know that x equals 4, you could substitute the 4 in. So you could say 3 times 4 plus 6 equals y. So then you would be able to say, oh, okay, so y is clearly equal to 18. Because 3 times 4 is 12. 12 plus 6 is 18. So you'd be able to finish this problem off by saying 18 equals y. Because that's what substitution is. You just plug in. It's just plugging in. Okay? So, if I want to solve this system for y, what you want to do is get one equation where the only variable is y. Because it says solve the system for y. Okay? So what you want to do is get one equation that the only variable in that equation is y. Alright, so right now I have x equals y minus 2 and x plus y equals negative 4. Look at this first one. This problem is actually a little simple. Look at this first one. X equals y minus 2. Since I know that x equals y minus 2, then anywhere I have an x, I can actually substitute in y minus 2. So now look at my second equation right here. Look at my second equation right here. X plus y equals negative 4. Well, I know that x is equal to y minus 2. So then I can replace this x right here with y minus 2. Okay, now I'm going to put parentheses just to show you I'm replacing. Parentheses actually aren't necessary, but I'm trying to show I'm replacing this x. Then I would still have plus y equals negative 4. So again, I knew that x equaled y minus 2. So in the second equation, all I did was replace this x with a y minus 2. So now these parentheses aren't actually necessary because there's nothing in front of the parentheses or right after the parentheses multiplying, so I can just drop them. That equals negative 4. So that gives me y plus y, which is 2y, minus 2 is equal to negative 4. Now I just got to finish solving for y. So I have to add 2. So I get 2y is equal to negative 4 plus 2 is negative 2. Oh, I wrote 2 equal signs, didn't I? 2y is equal to negative 2. Divide both sides by 2. You get y equals negative 1. So bam, that's your answer. Now what if you wanted to check it? How could I check my answer? Well guys, there are several ways. Okay, I'm going to show you one for this problem. Okay, since you know that y is equal to negative 1, you could go back to your both equations, plug in negative 1 for y, and you could see what you get for x. What you get for x should be the same thing in both equations. Okay, so let's do that. In the first equation, if I was plugging in a negative 1, so if I was to substitute in a negative 1 for y, I would get x equals negative 1 minus 2. So this is really easy. I could just say x equals a negative 3. Okay, now let's do it for the next equation. X plus y equals negative 4. So I would just say x plus negative 1 is equal to negative 4. Okay, now I need to remove the negative 1. So how do I remove negative 1? I add 1. Very good. So then I get x is equal to negative 3. Did I get x equals negative 3 on both of them? Yes, I did. So that means I know that y equals -1 is correct. All right? I know that it works. All right, let's do another example. Let's say I have two equations like this. Y equals 5x minus 7, and I have another equation, -3x minus 2y equals -12. Well, now this time I want you to solve for both x and y. So you're allowed to decide, do I want to solve for x first or do I want to solve for y first? It's your choice. Okay? What I do suggest doing is taking a moment and looking at the given information. Look here. You already have y equals. You know that y equals 5x minus 7. That means that I can replace any y with 5x minus 7. So what I would do is I would come down to my next equation, my second equation, and I would replace this y with 5x minus 7. Because if I do that, it's going to give me one giant equation with just one variable, the x variable. Now I'm going to have to combine like terms and whatnot and do some math, but I mean that now if you look at this equation I'm writing, the only type of variable you see is x. The fact that that's the only variable, it means I can actually solve this for x. Like I can get x equals a numerical value. So I can say -3x, and then I have to distribute the -2. So -2 times 5x is -10x. And then -2 times -7 is +14 is equal to -12. Now I just need to put likes up together and solve for x. -3x minus 10x is -13x. I need to move the 14 over, so I need to subtract 14 on both sides. So that's going to be equals because those two will cancel, and that's going to be -26. Then I need to divide by -13 on both sides. And I'm going to get that x is equal to 2. Bam! There's part of your answer. Now, this question says solve for both x and y. Okay, so now what you can do is you need to take what you just got for x and plug it back into either equation and solve for y. But once again here, I suggest that you pause first and think through which equation will be easier to use. In this second equation, we have -3x minus 2y equals -12. If you substitute 2 in for x here, you're still going to have to do some math. But look at this first equation. Y equals. They've already got y by itself. So I suggest using the first equation, plugging 2 into that one for x. So then you get y is equal to 3. So bam, your answer is 2, 3. All right. Okay, let's do one more problem. Okay, so our next problem, we're going to solve for both x and y again. Now, we have two equations, -5x plus y equals -2, -3x plus 6y equals -12. When you're looking here, you're going to realize I have not, how do I start? Where do I go? On the other two, I've always had some equation that already had a variable isolated. Okay, so let's take a breather. This problem wants to solve for both x and y. You get to decide how you want to do that. What I mean by that is, do you want to try to get x first or do you want to try to get y first? It's totally up to you, but here's my suggestion. All right, this is just a little hint. Look at both equations. Okay? I know that neither one of them have a variable already isolated. But which equation is it going to be easier to isolate for a variable, and which variable? What do I mean by that? Well, look at your first equation. Look at the first equation we have. -5x plus y equals -2. If I was to move this -5x over, wouldn't I get y by itself very quickly? I would. So let's do that. Y equals, and then I just say 5x because it was negative, so to move it over you have to add 5x, so now it's a positive 5x minus 2. I've isolated y. I have y by itself. Okay, so now what I can do is I can take the fact that I know that y equals 5x minus 2, and I can go plug it in for y right there. Because when I do that, it's going to give me an equation just in terms of x. So look at this new equation I'm writing right now. Do you see any other variable in it other than x? No. So you know the fact that it just has an x, you're going to be able to get x equals. So I can multiply. I can distribute, sorry, I should use the correct terminology. So I say -3x plus 30x minus 12 is equal to -12. Okay, Now I just need to put all the like terms together and move over anything that's not an x. So negative 3x plus 30x is 27x. Okay. Negative 12, to move it over, I need to add 12. Add 12. So that gives me, well, that gives me 0, doesn't it? Because negative 12 plus 12 is 0. So then I divide both sides by 27. And I get x is equal to, well, 0 divided by 27 is still just 0. So I know that the x value is 0. Now I need to get the y value. Alright, so let me show you anything you could do here. Okay? You need to take what you just got for x and substitute it back in for an x. Now, look at the three equations you have. Okay? When you look at these three equations, if you plug in x here or here, you're going to have to do some work to solve for y. But what about this one right here? Well, it's already got y by itself. So you can just say y equals 5 times 0 minus 2. See, I'm already going to have y by itself, so I'm not going to have to do any other work after I calculate this side. So that's why I chose that. So I can say y equals 5 times 0 is 0. 0 minus 2 is negative 2. So bam, there are your two answers. Y equals negative 2 and x equals 0. Okay? Alright guys, I hope this video made sense. Please let me know what questions you have. Please, feel free to send me a reminder, send me an email, leave a comment if you have a question. I'll try to get back to you. Thanks.